In this episode, we focus on two disciplines that can sound administrative at first, but are actually some of the strongest predictors of whether a system remains secure after the first release: configuration management and quality assurance. Beginners often picture security as something you design into architecture or implement in code, and those things matter, but many security failures happen later because the system drifts away from its intended state. Configuration management is the discipline that keeps the system's state known, controlled, and traceable as it changes, while quality assurance is the discipline that keeps the system's outputs and processes consistent with agreed standards and expectations. When these are weak, teams lose the ability to prove what is deployed, to understand what changed, or to prevent defects from reappearing again and again. When they are strong, security becomes easier to maintain because change is disciplined, defects are caught earlier, and evidence of control effectiveness is easier to produce. The exam often tests whether you understand that secure systems are not just built. They are maintained through reliable operational habits that preserve intent under real-world pressure. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at Cyber.Author.me in the Bare Metal Study Guide series. A solid starting point is to define configuration in a way that includes more than settings and makes clear why configuration is security relevant. Configuration is the collection of choices that determine how a system behaves, including what components are present, what versions they run, what permissions and roles exist, what services are enabled, and how the system connects to other systems. Configuration touches almost every security control because access rules, logging behavior, and boundary protections often depend on configuration more than on code. Configuration management is the disciplined practice of defining approved baselines, controlling changes to those baselines, and recording enough information to understand who changed what, when, and why. Beginners sometimes assume that if the system is initially configured securely, it will remain secure, but in practice systems are constantly adjusted for performance, feature needs, troubleshooting, or convenience. Without configuration management, those adjustments can create hidden exposure that nobody notices until an incident happens. When you treat configuration as part of the security surface, configuration management becomes a security control that protects both stability and assurance. Baseline is a key concept here because it gives configuration management a reference point, and without a reference point you cannot detect drift. A baseline is an approved, known good state that represents what the system should look like when it is operating securely and correctly. Baselines matter because they allow you to compare the current state to the intended state and to detect unauthorized changes, accidental deviations, or gradual drift. A common beginner misunderstanding is that a baseline is something you set once, but baselines evolve as systems evolve, and the discipline is in controlling that evolution so each new baseline is approved and traceable. Baselines also support repeatability, meaning you can rebuild a system in a consistent way and have confidence that it will behave the same, which is essential for both quality and security. In exam scenarios, when you see repeated inconsistencies, unclear system state, or difficulty reproducing issues, the underlying problem is often weak baselining and poor configuration discipline. A strong answer often emphasizes establishing and maintaining baselines as the foundation for secure operations. Change control is the engine of configuration management, because configuration management is not about preventing change. It is about making change safe and accountable. Every change has security implications because it can alter permissions, expose new interfaces, disable logging, introduce new dependencies, or modify how data is handled. Change control means changes are proposed, evaluated for impact, approved by the right authority, implemented in a controlled way, and recorded for traceability. Beginners sometimes hear change control and picture slow bureaucracy, but uncontrolled change often creates much bigger delays through outages, incidents, and painful troubleshooting. A well-run change control process scales effort based on risk, so low-risk changes can move quickly while high-risk changes receive deeper review and stronger evidence requirements. This risk-based approach keeps delivery moving while still protecting security intent. Exam questions that involve emergency changes, repeated regressions, or unclear accountability often point toward change control that is either non-existent or bypassed, and the most defensible response is to restore disciplined, proportionate change management. Versioning and traceability are also central, because configuration management must be able to answer the simple but critical question of what is running right now and how it differs from what ran yesterday. That includes versions of software components, versions of configurations, and the relationships among them. Without version awareness, it is difficult to diagnose incidents, because you cannot tell whether a vulnerability exists in the deployed version or whether a fix has actually been applied. It is also difficult to satisfy assurance expectations, because evidence collected for one version may not apply to another. Beginners sometimes think versioning is a developer-only concept, yet operations needs versioning just as much to maintain stability and confidence. Traceability also supports accountability, because it ties changes to approvals and to the individuals or processes that perform them. When incidents occur, traceability helps you determine whether the incident was caused by an external threat, an internal mistake, or a hidden drift. The exam often rewards answers that emphasize being able to reconstruct system state and change history, because that capability is a cornerstone of secure operations. Quality assurance complements configuration management by focusing on consistency, correctness, and disciplined processes that prevent defects from repeatedly entering the system. Quality assurance is not just testing. It is the practice of ensuring that how you build, change, and operate the system follows standards that lead to reliable outcomes. In a security context, quality assurance includes making sure security requirements are treated as quality requirements, meaning they are built into acceptance criteria and verified repeatedly. Beginners sometimes treat security defects as separate from quality defects, but many security issues are quality issues that involve incorrect handling of input, incorrect enforcement of authorization, or unsafe error behavior. Quality assurance also includes process consistency, such as whether reviews happen, whether changes are documented, and whether incident lessons lead to improvements. When quality assurance is strong, the system becomes more predictable, and predictable systems are easier to secure because you can reason about their behavior and measure deviations. In exam scenarios, when issues recur and fixes do not stick, the likely problem is weak quality assurance discipline, not simply missing knowledge of controls. A crucial connection between configuration management and quality assurance is the idea of preventing regression, which means preventing old problems from coming back after a change. Regression is common in complex systems because changes can have unintended effects, especially when dependencies are unclear or interfaces are loosely controlled. Configuration management helps prevent regression by keeping changes controlled and traceable, while quality assurance helps prevent regression by ensuring changes are verified against requirements and that known issues remain fixed. Beginners sometimes assume that once a problem is fixed, it stays fixed, but without disciplined processes, fixes can be undone accidentally, such as by reverting configurations, reintroducing old components, or bypassing controls during urgent troubleshooting. Preventing regression is important for security because attackers exploit recurring weaknesses, and repeated reappearance of issues erodes trust in the system's assurance story. Exam questions about recurring incidents or repeated findings often point to regression, and strong answers involve tightening configuration baselines and strengthening quality checks that confirm fixes remain effective. This approach is not glamorous, but it is profoundly practical. Operationalizing these disciplines means making them part of normal daily work rather than treating them as special tasks that happen only during audits or major releases. In practice, operationalizing configuration management includes maintaining accurate inventories of system components, keeping baselines current and approved, documenting changes reliably, and monitoring for unauthorized drift. Operationalizing quality assurance includes defining quality criteria, performing consistent reviews, verifying security behaviors as part of acceptance, and using feedback from incidents to improve processes. Beginners sometimes think operationalizing means adding heavy overhead, but the goal is to design processes that are light enough to be followed consistently. A lightweight process that teams actually follow creates better security than a heavy process that teams bypass under pressure. Operationalization also requires clear roles, because configuration and quality cannot be nobody's job. Ownership must be explicit so accountability exists. On the exam, when scenarios mention confusion about what is configured, inconsistent environments, or inability to prove control effectiveness, the answer often involves operationalizing these disciplines so evidence is produced continuously rather than reconstructed later. Monitoring is an essential component of operationalized configuration management because it provides the signals that reveal whether the system is still in its approved state. Monitoring here is not only about detecting attacks, it is also about detecting drift, unauthorized changes, and misconfigurations that can create exposure. For example, if logging is disabled, if an access rule changes unexpectedly, or if a critical service becomes exposed to a wider network than intended, monitoring should reveal those deviations. Beginners sometimes assume that monitoring is separate from configuration, but monitoring is how you maintain confidence that configuration controls are still working. Monitoring also supports quality assurance because it reveals whether the system behaves reliably and whether operational errors are increasing. When monitoring is tied to baselines and to expected behaviors, it becomes an ongoing verification mechanism rather than a collection of random alerts. In exam scenarios, a lack of visibility is often the root cause of delayed response and weak assurance, and strengthening monitoring is a common part of the solution. The key is that monitoring should support traceability, meaning you can connect an alert to a specific change or deviation in configuration. Incident response and problem management also intersect with configuration management and quality assurance, because incidents often reveal where discipline is weak. When an incident occurs, responders need to understand system state, recent changes, and what evidence exists, and configuration management provides that context. Quality assurance contributes by ensuring that known failure patterns are analyzed and that lessons lead to process improvements, not just one-time fixes. A common beginner mistake is treating incidents as isolated emergencies, but mature operations treat them as learning opportunities that strengthen baseline controls and reduce future risk. For example, if an incident was enabled by an unauthorized configuration change, the response should include tightening change control and improving drift detection. If an incident was enabled by a repeated defect, the response should include improving verification practices to prevent regression. This is where operational discipline becomes part of assurance, because assurance improves when the organization learns and adapts in a structured way. Exam questions often describe organizations that experience the same incidents repeatedly, and the best answers frequently involve strengthening operational disciplines rather than adding yet another isolated technical control. A beginner-friendly way to connect these ideas is to think about how configuration management and quality assurance create reliability, and how reliability supports security. Secure systems must be predictable, because security depends on knowing what should happen and recognizing when something else is happening. Configuration management makes the system predictable by controlling what is deployed and how it changes, while quality assurance makes it predictable by ensuring processes consistently produce correct outcomes. When predictability is high, it is easier to detect anomalies, to investigate incidents, and to maintain evidence that requirements are still met. When predictability is low, security becomes a guessing game, because you cannot tell whether behavior is malicious, accidental, or simply inconsistent configuration. Beginners sometimes focus on advanced threats and miss that basic operational chaos is itself a threat because it creates openings and delays response. Operationalizing configuration and quality reduces that chaos and therefore reduces risk. In exam reasoning, this means that answers emphasizing disciplined baselines, controlled change, and repeatable verification often represent deeper security engineering thinking than answers that focus only on adding new barriers. Another important point is that these disciplines scale, meaning they become more important as systems become larger, more distributed, and more frequently changed. In small systems, people sometimes rely on informal knowledge, but in large systems, informal knowledge fails because no one person can keep the full state in their head. Configuration management provides a shared truth about what exists and what changed, and quality assurance provides shared discipline about how changes are evaluated and accepted. This scaling property matters in modern environments where systems may include software services, virtual infrastructure, and cloud resources all changing on different cycles. Without operational discipline, security becomes fragile because change outpaces understanding. With operational discipline, change can be fast and still safe because state is known, changes are controlled, and evidence is refreshed. Exam scenarios that involve complex environments, frequent releases, or multiple teams often reward approaches that strengthen these scalable disciplines. The answer is rarely to slow everything down. It is to improve the processes that allow safe speed. As we close, the central message is that operationalizing configuration management and quality assurance is one of the most effective ways to keep systems secure over time because it preserves intent, prevents drift, and creates repeatable evidence. Configuration management keeps baselines defined, changes controlled, and system state traceable, which supports both incident response and ongoing assurance. Quality assurance keeps processes consistent and outcomes reliable, which prevents security defects from recurring and ensures security requirements remain part of what it means for work to be complete. Together, they reduce regression, improve visibility through monitoring, and turn incidents into structured learning rather than repeated chaos. For ISSEP-style thinking, the key is recognizing that security is not only about the controls you install, but about the discipline that keeps those controls effective as the system evolves. When you can describe how baselines, change control, verification, and monitoring work together to maintain trustworthy system behavior, you are demonstrating mature security engineering reasoning. That reasoning will help you answer scenarios where the real problem is not missing knowledge, but missing operational discipline that keeps security real in day-to-day reality.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.